demo page, this is where I have all those different demonstrations and stuff. And copy a line segment, we've already done that. Sum of line segments, we've done that. Different perpendicular bisector of a line segment. So now we're going to look at perpendicular to a line, perpendicular to a line from an external point. Okay? So if you look at this particular video, okay, and ignore the King Supers ads, okay, we're going to look, but you can get fresh Norwegian 7 fillets for only $7.99 a pound. I would highly recommend them, but with your King Superstar. All right. I don't know how we get rid of this. Anyway, so we're on this page, and rather than me do it on the compass, you could just kind of pull that up and look at it. Where'd my tools go? Okay. And first thing you do, so this is what you have. You have a line, not necessarily a horizontal line. Right? It could be going at any angle, and a point. And you want to construct a perpendicular from this point to this line. All right. So if I am going to do a perpendicular, say I want to go. Say someone says to me, "Let's go the shortest." Well, let's not talk about that yet. Well, I'll just show you how to do it. So, or they will show you how to do it. So you take your compass, you stretch it out. You should follow along with these guys. Okay. So just try to do these kind of hands-on if you can't get it. You don't have to make your line perfectly horizontal. You stretch out your compass from a point. So you make a point not on the line, and you make a line. So this is different than bisecting a segment, because the segment has endpoints where you put your compass. This does not have endpoints, okay? So you take your compass, and then you make 2 marks on this line from that point. So your compass has to at least reach the line. It has to be longer than the line. Okay? Are you doing this? Do you have a compass? You should do this with me so that I can make sure you're doing it right. Okay? Or not with me, but with the demo people. I would do this on the board. I can't do it. Okay? So you do that first. Then, any questions on that? You just hit that in 2 spots. Okay? Then your new points are going to be, so now it becomes kind of like doing the perpendicular bisector. You're going to put your compass on those 2 points. Okay? And just like you did with the perpendicular bisector of a segment, you're going to stretch out your compass more than halfway. Okay? So let's see what they do next. Okay? So they stretch out their compass more than halfway, and then they make 2 marks below the line. Okay? So putting your compass on this point and that point, let's go back, okay? Putting your compass here and here, you stretch it out so that it's about 3/4 of the way across. And then you make 2 hash marks. Now since you already have a point here and a point there, then you just connect those 2 points using your ruler, boom, and you've got a perpendicular from a line to a point that is not on the line, okay? Are you guys all able to do that? You all did it? If you have questions, let me know. I want to see how you can do it. Let me walk around. Let me walk around. Unpause. I'm going to go back to here. Unpause. I'm talking now, right? Okay, so if I go back to my Schoology, and over here I put your conjecture sheet. Anyone not have the conjecture sheet that I gave you the other day? Anyone need that? There are conjectures from this chapter. Let me find it. Anyone else need that? It's green. Looks like that. Okay. Anyone else not here? Oh, you have that. That's our back to Katie. Okay. So, how come that's not opening? Let's open that. Open. There it comes. So I'm opening this up, and in a second. Where is it? There it is. Maybe. Okay, I'm waiting. There it is. Enable that in. So, next conjecture, conversion of, we talked about that. So this conjecture right here, C7, says that the shortest distance from a point is measured along the length. So if I, in other words, if I wanted, so here's some line, right? That's not a line. Here's a line. Here's a line, okay? And here's a point over here. And I say, go the shortest distance from this point to that line. How am I going to go? Am I going to go like, am I going to go like this to get to that line? Am I going to go like this? No, I'm going to go straight towards it. And what would have to be true about that point right there? It would have to be perpendicular. So if you want to go the shortest distance from point to a line is measured along the word that goes in there is the perpendicular. Okay? Perpendicular from the point to the line. Okay? So if you want to get the quickest way from point A to a line, you go on the perpendicular. So if I want to get out to 88th Street out there, right? Probably the fastest way. Wait. Oh, here you go. Wait, oh, you have a message. Message for you, I think. So if I want to get to 88th Street, and I want to get there the quickest way, I have to go on the perpendicular. There might be stuff in the way, so then I couldn't go straight up. Like I have to walk over the K8 out there or something, right, to get there. But in any case, so that's conjecture C7. God bless you. So that's that conjecture. Now let's move on to another construction, because these are fun. Okay? So where'd my construction thingy go? Is that it? No. Demos? Okay, so we're going to go back to this one. Open, add choices, go back to the next one, which is very similar, perpendicular to a line at a point on the line. Okay, so this is this one. So say you have this situation. I don't really like theirs because it's always horizontal. This line doesn't always have to be horizontal. So when you're doing this, you might want to draw a line kind of in an angle or something like that, and put a point on that angle. Okay. Put a point on that line. So they put a point somewhere on this line, and they want to make a perpendicular coming out of that point. Okay? So all you have to do is put your compass there, keeping the same setting, okay, on that point. I just stretch my compass to some arbitrary distance, and I make a mark on one side, and then I make a mark on the other side, like that. Got it? And then you just do the exact same thing that you did with the perpendicular from a point not on a line. Okay? So then you're going to put your compass point here and here. And you have to set it to somewhere more than halfway across, otherwise it's not going to meet, right? So after you make those two marks on your line, I set it about to 3/4. Questions yet? Am I going too fast? We're good? And then you hit next, and you make a mark where you think directly above is, and then you flip your compass, keeping the same setting, make a mark there, and then you just connect those dots, and then you have a perpendicular coming out of there. Okay? Not so bad, is it? You have this point here, so you don't have to, you can make marks down here as well, like you're doing the perpendicular bisector of this segment, but you don't have to, because you're just connecting this point where those two arcs intersect to that point, and then that thing's going to be 90 degrees. Okay? This is the basis for making a square. Okay? Say they said, I'm not sure if they have this video on here. Let me go back. back to the square, okay, or see if they do have a square. Bisect, perpendicular, triangles, right triangles, triangles, circles, tangents. So look, ooh, they got some good ones. Equilaterals, altitudes of a triangle. Oh wait.
There was at the bottom, there's polygons.
Polygons. Square given one side. Oh, so for a square given one side, what's this video going on here? Let's just do that. Square given one side. Okay. Next. So you start with a side, right? Then, so say you want a square with this as your length of a side. If I make a perpendicular coming out of either of those points, right, then I'm going to have a right angle, okay? So what they do first, they extend that side. You don't have to do this one with me. This will be one of your homework problems, okay? So they extend the side, and then they make a perpendicular coming out of point B. See that? Okay? And keep going. They do the construction that we just did, okay? So you, so the side of your square is going to be AB. Then you make this perpendicular going straight up. Okay. And then, since the square has all the same lengths, you take your compass and you measure the distance from here to here. Okay? I think that's what they'll be doing next. Oh, yeah, from here to here, sorry. That's one length of the side. You pick up your compass and you make a mark up there about where you think that other side of the square is going to be. Okay? Then you move the compass over to here and you make a mark there. Okay? You only have to make one right angle, because if you have one right angle and four congruent sides, it's going to be a square. So what they did is they measured this distance AB, they made a little mark there, they made a little mark here. Then guess what I do next? Who wants to guess what I do next? Go to point C and put your compass there exactly, Ryan, and then cross this right there. Because this length is the same length as this length, the same length as this length, same length as this length, and I already have my one right angle. We'll learn about properties of polygons later, but because of that, all four of those angles are going to be right angles. And then you have a square of, then you have a perfect square. So all you have to do is make one 90-degree angle, copy the length of the side, and then you'll have a square. Okay? The other thing that I want to talk about is altitudes of triangles and bisectors. Okay? So I'm still recording. So if I have a triangle, triangle, let's make a triangle. Freehand, straight. Tools, I have to look at my tools. Watch this is my favorite tool. Freehand, where's my freehand shape tool? This one, okay? This is fun. I can make a triangle. Say, that doesn't look like a triangle. It fixes it. Isn't that cool? Okay, so when you have a triangle, anyone know what an altitude is? If they say the altitude of Mount Evans is 14,000 feet, what does that mean? The height above sea level. If I were to drop a line down to the ground perpendicular, that's the altitude, okay? So when you're talking about an altitude, that is a perpendicular. So if I were to go from this point perpendicular to the other side, okay, whoops, I don't want arrows on the end, okay? Let's change that so I don't have an arrow there, okay? This would be an altitude. Okay. And you can have an altitude from all three vertices. Okay, so an altitude, you should maybe write this down. Altitude is the perpendicular segment from a vertex to the opposite side. Okay. Okay, so in this case, if this is triangle A, B, C, this would be altitude AD. Altitude AD with a line. How many altitudes do I have in a triangle with that definition? 3, right? So I could have another altitude over here, okay, going from here to here. And you have to make sure it's perpendicular. See? There's another one. I'm going to make sure that's perpendicular. I could have another altitude going from here to here. We'll discover some properties about those altitudes, like, oh, looks like they all intersect at the same point. We'll discover that eventually. But all 3 of those things are altitudes, okay? So I have altitude BE, and altitude C, we'll call this CF. CF. Okay? So there's 3. Now you gotta be careful, because sometimes altitudes, where's my, oh, I have to get that tool again. New sheet. So, tools, I should put that on my clipboard. Freehand shape. Where is it? Freehand shape. There it is. Okay. So sometimes if I have a triangle that looks kind of like this, okay, is that a triangle? There we go. Where would the altitude from side A to side BC, from vertex A to side BC be? Where would it be? If I were to drop a rock off here, where would it fall?
Oh, it would be outside.
It'd fall outside a triangle. So sometimes the altitudes fall outside of the triangle, okay? So for instance, in this case, what I have to do is extend the side. Usually you indicate that with a dotted line. So I'd extend this side, and then I would I'd use my compass. I'm going to show you how to construct an altitude. In this case, the altitude to this opposite side is outside the triangle. So we'll call it AD. So this is altitude, AD falls outside of the triangle. Triangle ABC. You get that? Okay. This one would probably fall outside as well. BA, you would have to extend this side. I'll show you that. Right? Here's BA. You'd have to go like this, extend that side, and then make this altitude going this way. It's kind of weird, but there's that altitude to that side. How about the altitude from C? Would that be inside or outside the triangle?
Inside.
That one would be inside, right? So in that case, that one would be inside the triangle. So in some cases, altitudes can fall outside the triangle if you have an obtuse triangle like that, okay? So you have to be careful with that. How do you construct an altitude? So I'm going to go back to this, okay? Back, I think it shows you, okay? Constructions, I could show you with my compass, but they're better at it. Altitudes of a triangle, there we go. Altitudes of a triangle. So an altitude you do the same way is from a point to a line. Okay, so say I want the altitude from constructing the altitude of triangle PQR. So if I want to construct that perpendicular from here to here, okay, I do it. What are they doing? Oh, they're extending this side. So maybe they're going to do R from point R. So now what I do, just like I'm doing from a point to a line, they hit this line in 2 spots, there and there. Okay?
Mr. Leader,
Yeah.
could you move a
Sorry.
little?
So they put their compass point here. They extended this side, so I'm sure that I hit this side in 2 spots. Okay, and then they just put their compass on those 2 points and make a mark here, and they flip it around, make a mark there. And now I'm going to connect this point to that intersection over there. And I hit next, connect it. They go all the way. The altitude is actually this part of it, right? The altitude isn't the entire thing. It's just this piece right here. but you have to construct the whole thing to make that altitude, okay? So that's how you do an altitude. You'll have some of those in your homework. I want to move on to the next thing. Back, 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 next. What's that? Oh, they did it. Boom, boom, boom. Again, you could run these over and over again if you don't remember. Okay, next, next, next. Go in fast motion. Okay. We're good? You can practice these on your, okay? Next thing we're going to learn how to do is an angle bisector, okay? So when you do an angle bisector, right triangles, triangles, and centers, angle bisector, bisect an angle, right here, okay? You should all do this one with me, okay? So make an angle on your paper, an acute angle, any type of angle you want, okay? Or an obtuse angle, doesn't matter. And make the sides nice and long so you have room on them, okay? So we're going to be bisecting some arbitrary angle. And all I do is I make an angle, construct a line which bisects angle PQR, okay? Take your compass, stretch it out to any length, okay? Any length, and put it on the vertex of your angle, okay? Am I still in your way? Kind of. Okay, here, I'll go over it. Okay. Then, mark off a mark on that side, and mark off a mark on the other side. Okay? So, and when I'm looking for constructions, when you do a quiz or when you do your homework, I'm looking for these marks. So make them so that I can see them. Okay? You don't want them to be teeny little points. Don't make them invisible. I want to see your actual marks because that's what I'm grading on. Okay? Now all you do is you pick up your compass, okay? And you can keep the same length or you can make it longer or shorter, okay? But you make a mark out here and then you pick up your compass and you put it on this mark, keeping that same distance. And then all you do is you connect this point right here to that point right there, okay? So, boom. Hey, what happened? It stopped. There you go. Okay? And that's how you do an angle bisector. Piece of cake, right? Yes? Okay. So, any questions on that? Are you guys able to do that? What do you think is true about the distance? If I were to measure the distance, say I were to put a point on this angle bisector, okay? And I were to go perpendicular to this side, anywhere on that point. If I were to measure this distance and this distance, what do you think is true about those two distances? They're the same. As long as you go perpendicular to there and perpendicular to there, those two distances are the same, okay? And that's conjecture C8, okay? It says, let me grab this one, partial face capture. If a point, I should probably grab that picture. Let me go back. Can I do that? Never mind. Going back, going back. I'm going to grab this picture. Partial. I'm not going to put on the image. Oh, I don't want it there. Edit. Edit. Copy. Go forward. Edit. Edit. Paste. Okay. A picture, something like this would be nice. Okay. If a point is on the bisector of an angle, then it is blank from the sides of the angle. What do you guys think goes there? Equidistant. Okay? Same distance. Equidistant. And all of these, it's not just magic. Next, next chapter, chapter 4, is all about congruent triangles, and you'll find out that what's behind the scenes here are these triangles are congruent, and you can prove that those triangles are congruent. Okay? So if I were to put a point here, what would have to be true about the distance from here to here and the distance from here to here? Those would have to be the same as well, right? So any point on the perpendicular bisector of an angle is equidistant from the sides, okay? And see, that's it, okay? And so then, what's nice about this, these perpendicular bisector, or excuse me, the angle bisector, is that now you can make a, how do I go back? Go back. You can construct a 30-degree angle, a 45-degree angle, a 60-degree angle, a 90-degree angle. Anyone tell me how I might construct a 30-degree angle? What would I have to know how to do if I'm constructing a 30-degree angle? I'm not even going to do it. Remember how we constructed an equilateral triangle? Okay? You started with a segment. Okay? I'm going to make this solid. The equilateral triangle, you start with a segment. You put your compass like here and here. And then I put a point. I take my compass. I actually have a compass. Watch this. This is really cool. Compass. Okay? It's not that cool. I take my compass, look at this. I measure this distance, and then this is where it gets tricky. Then I take it and use it, I have to rotate it. How do I rotate it? What is this? That moves the compass. This, I have to remember how to do this. This is why I don't use this thing. That opens and closes it. I think, here we go. I'm going to take this compass, I'm going to put the point, I'm going to do my equilateral triangle. Wait, can I move it down here? There we go. No, I'm going to take, I made my segment too long. Let me try again, okay? And I start a new page. New page, new page. I'm going to make a shorter segment. Here's a shorter segment. Now I'm going to take my compass tool, compass. I'm going to take it and I am going to move, I'm going to make a mark up there. I'm going to take this point. Can I do that? I don't know how you make it so it doesn't draw. And I cross that there, okay? So really what I do is I put my compass point here, and I cross it. And then when I connect those two, I have an equilateral triangle. I've talked about this. You're supposed to do this in homework. So what is each one of those triangles, what do each one of those angles in the equilateral triangle have to be? 60 degrees. So if I were to bisect one of those, right? Bisect that, right? Then what does each one of those angles have to be? 30 degrees, right? That's how you make a 30 degree angle. If I bisected 90, what do I have? 45. If I bisected 30 again, what do I have? 15. On the other side would be a 75. Okay, and so on. So going back, let me just see how they do. Construct a 30-degree angle. Okay, so you can watch these videos. Let's just run the whole thing without me touching it. So they start by drawing a segment. Then they stretch their compass. How do they do it? Oh, they make... So they're... Whoa. What? Oh, what they do, they made this arc here. And this thing where this intersects, that's gonna, I don't know, that's weird, okay? But I think what would happen if I connected these points, I'm not sure what's at work here, but this would make an equilateral triangle, would it? No.
I think it's because the video is constructing a 30-degree angle.
Yeah, I know, but it's... That's confusing to me. That's not using a 60-degree angle. I would go, where's the equilateral triangle? Construct an equilateral triangle. Right triangle, circles, polygon, square. Right triangle. Where is it? You see? Oh, there it is. Okay. So when they do an equal, I kind of like you to do it this way. Okay. So you start by having a line segment, stretching that length. This is the way I did it. Okay. Making a mark there. They do it different than I do. What?
Oh, we're not building it all. So yeah, they're not building it off the same.
Oh, okay. So that's how you do. So there's a, what's this? AB with this side line. So that would be an equilateral triangle. And then if I bisected that, right? If I bisected that equilateral triangle, any angle, each one of those would be 30 degrees, right? And that'd be 60, right? And if I wanted to make like a, what would this angle here be? 120, right? So this is 60, that's 120. Then the angle from here to here would be what, 150, right? And so on and so forth. So I think that's enough. I think you can figure out the rest, all right? So I'm going to stop and give you guys some time to work and get started on some of those constructions. You only have about 10 minutes, but and